Hello students, Callie Daniels here. In this video we're going to talk about algebra, linear equations in two variables, and more specifically linear equations and rectangular coordinates. Well, let's begin with example 1, interpreting a line graph. Here in part A we want to estimate the average price of a gallon of gas in 2010. And we've got a graph to look at from the U.S. Department of Energy. And notice along our horizontal axis, or you might think about the x-axis, is the year, 2005, 2006, and so on. And then on our vertical axis we have the price in dollars per gallon. So the price for a gallon of gas in dollars. And you notice this little break in our vertical axis that just says, hey, there are some missing numbers between 0 and $2.20. All right, so back to our question, estimate the average price in 2010. Well, let's locate 2010 on our horizontal axis and follow that up to the graph. Here we see a point. Okay, with its, you might think it's X value, the year 2010. And now let's consider what the corresponding price per gallon of gas would be, and that's $2.80. Again, that's a price in dollars, and that's our estimate of the average price in the year 2010. Now in part B, about how much did the average price of a gallon of gasoline increase from 2010 to 2012? Well, let's take a look at 2012 and follow that year up to our graph. So in the year 2012, it appears that the average price of a gallon of gas is right about halfway between $3.60 and $3.80. So let's estimate that at $3.70. Now we were asked for the increase. So we want to find the difference. 370 minus 280. And that's right about $0.90. Okay, so there's our increase, or you might say that increase was about 90 cents. Well, moving on, let's define a linear equation in two variables. It is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. And this form that we're looking at is called standard form. Okay, standard form occurs where our variable terms a, x, and by are on the same side of the equation. We won't see fractions and decimals in what we call standard form, and our coefficient of x would be a positive number in standard form. So some examples of standard form of linear equations in two variables are 3x plus 4y equal 9, x minus y equals 0, x plus 2y equal negative 8. Now let me back up and just kind of point out this little restriction in our linear equation. Your coefficients of x and y can't both be 0 at the same time. Well, one of those coefficients could be 0, in which case we can have linear equations with only the y variable or only the x variable, and we'll see some of that later on. Next, let's talk about a solution of a linear equation in two variables. Okay, it requires two numbers, one for each variable. For example, a true statement results when we replace x with 2 and y with 13 in the equation y equal 4x plus 5. So notice we've got a linear equation in two variables. We see x and y. And if we just check this out, and replace x with 2 and y with 13. Let's show that this does indeed give a true statement. Here we go. is 13 equal to 4 times 2 plus 5? Is 13 equal to 8 plus 5? And it is. This is indeed a true statement. And we would say the ordered pair with x value 2 and y value 13 then is a solution of our linear equation because it works. It satisfies the equation. Well, let's do some more of this in example 2 as we decide whether each ordered pair is a solution of the equation 3x minus 7y equal 19. Starting with part A, okay, is 3, 4 a solution? Well, 3 is the possible x value and 4 the y value. When we write an ordered pair, we always write x first, then y. And so we substitute 3 for x, 4 for y, and let's see if this gives a true statement. Is 9 minus 28 equal to 19? No, we get negative 19 on the left, and that's not equal to positive 19. This is a false statement, and 3, 4 is not a solution, okay, to our equation 3x minus 7y equal 19. Well, let's see if negative 3, negative 4 is a solution to this equation. So again, we're just going to substitute our x and y values in the appropriate places and see if we obtain a true statement. So negative 3 in for x, negative 4 in for y. Is that really going to give us 19? Okay, in other words, is negative 9 plus 28 equal to 19? And it is. That is a true statement. And therefore, we would say that our ordered pair, negative 3, negative 4, is a solution. And I'm abbreviating the word solution there just to be quick with it. Well, here's our last example for this video. We're going to complete a table of values to determine ordered pairs for the given equation and plot the given points in a coordinate system. So our first equation is y equal x, and this is the most basic of all linear equations. As we generate solutions, and I'm going to write those solutions in a t-table, okay, where we write x on the left and y on the right. Let's just put in some x values, like maybe if x is negative 4, and we substitute negative 4 for x, then y would also be negative 4. Y is equal to x. Whatever we put in for x, y must match that. If we let x equal negative 2, y is equal to x, so it must also be negative 2. You might think, well, I'm going to let y equal 0. Y is equal to x, so x must also be 0. And we could generate infinitely many ordered pairs that satisfy this equation just by putting in our t-table x and y values that are equal. Oh, let's try one more. What the heck? If x is 7, y is 7. Well, let's plot these ordered pairs, beginning with negative 4, negative 4. Okay, that's down here in quadrant 3, x equal negative 4, and y equal negative 4. And as we're plotting these, you're plotting your x values along the horizontal axis and your y values along that vertical axis. Negative 2, negative 2. We have the point at the origin, 0, 0. That point is the origin of our Cartesian coordinate system. And we've got a point out here, 7, 7. Now it takes only 2 points to determine a line. We've got 4 points, and when we sketch this line, which is a picture of all of the solutions of our linear equation. Okay. Notice that it contains all of our points from our t-table. And this again is the line y equal x, the most basic of all lines. And all non-vertical lines are some manipulation or translation of this line y equal x. That's a good one to remember. Well, let's look at part B. 2x minus 3y equal 12. And again, we're going to create a t-table of values. Now, this one's a little bit more difficult. We're actually going to have to do some work, but I like to work with zeros when possible. In this equation, okay, just choose any value for x or any value for y. It doesn't matter, okay? But choose some values that are going to show up on our grid that we have shown here, okay? So if we let x equal 0 and we substitute 0 for x, and we solve for y, then we get y equal -4. So one solution to our equation is 0, -4. And we call this point the y-intercept, because that's where the graph of our line intercepts, or you might say intersects, the y-axis. And you can always assume that our horizontal axis is x and our vertical is y. Well, let's turn around up here and let y equal 0. Well, if y is equal to 0, 3 times 0 is 0, and that term is going to disappear, isn't it? Okay. And that's going to leave us with the equation 2x equal 12. In other words, x is equal to 6. And this we call our x-intercept. Coordinates 6 for x and 0 for y. Now, again, 2 points determine a line. And so all we really need are those 2 points in order to sketch our line, which is a picture of all of the solutions to this equation. There are infinitely many solutions. Let's say we find one more just to use as a checkpoint. You'll get good at choosing values for x or y. I've done a little pre-work. And I think a good value to go with is -3 for x. And if we substitute that into our equation, that'll allow us to avoid fractions, okay? So that's -6 minus 3y equal 12. Add 6. Divide by -3 to obtain y equal -6. Okay, again, how did I know to do that? I did a little hunting and pecking before the video, okay? So if x is -3, y is -6, and it does appear that that point is on our line. So I'm feeling pretty good about my work. I don't think I've made any mathematical errors, and we've got a good picture of the graph of the equation 2x minus 3y equal 12. So here we've had an introduction to linear equations in two variables and some basic graphing techniques. Students, remember to keep working hard, okay? Show up, work hard, stay positive.